used for lead. The magnitudes of these is very similar to what the model predicted as the junction concentration in upstream. That's because it's a flow-weighted concentration, and less dilution occurs in upper areas. Again, these three junctions here in the lower region correspond to these three. So it shows you that these are the farthest, most upstream junctions that cause the greatest pollutant concerns. The best and possibly the only way to then remediate these concentrations is to change the input EMCs to what the actual water quality standard is. Doing that, oops, excuse me, wrong button. Doing that, as you see here, reduces the magnitude of all the predictions, and then, okay. And then also results in zero water quality violations. I had mentioned earlier that there was an assumption about the attenuation factor. And this is just a sensitivity study to show that using different values of the attenuation factor still produces the same shape and still produces the same junctions of concern. So that validates our assumption. We also compared our model with an established USGS model. I had said earlier subwatershed 42 is small and 53 is big. You can see here in the smaller watershed, the models predicted almost identical loads, whereas in the larger one, the USGS model was much larger. That's because the USGS model is more dependent on land area than our model is. And just to get into some summary, the runoff model was developed specifically for the Armendariz River watershed in Cuba. Non-point sources were linked with in-stream concentrations, depending on urban and non-urban areas. Hydrologic and water quality data was taken from South Florida, and model uncertainty was built into that. We provide a relative assessment of which junctions are most likely to be of concern. And then some conclusions. The junctions of concern are in upstream areas. Dilution and attenuation help reduce downstream concentrations. Remediation efforts should focus on reducing EMCs in upstream areas. This is showing that the land use directly affects what the in-stream concentration is. The model is comparable to the USGS model, and our model can be readily adapted to other watersheds in Cuba. This is especially useful in areas with little or no data, like we can assume that most of the rest of Cuba is that way. And it's also ultimately helpful in reducing risk to human health. So thank you.